Hi everybody, and welcome to the Smart Start in Life Sciences. I am Miss Angler. In today's video, you are going to get a masterclass, a one-on-one session with me where I share all of my exam tips, my experience marking final matric papers, and I'm going to make sure that you are well equipped for your final exam or the assessment that you have coming up. Now, these particular videos are structured in a way that you can work through the topics, and as we progress, we're going to work towards a final set of questions. Throughout the video, I'm going to clear up all of those misunderstandings that you have. Why do you keep getting it wrong? And then we're going to end off with a section on the questions that I've provided you. These two sets of questions are in two categories. Recall questions, which is ultimately questions that will lead you to get around 50%. But if you are aiming for that distinction, then you need to move on to the application questions that I have provided. Now, these questions that I provided, they are handpicked. I've gone through past papers, I've selected what I think is best, and they will give you a good indication if you are ready for your assessment. So let's move into paper one exam preparation tips. Now, everybody hates paper one, and there are some key reasons why we don't do well in this particular paper. And I all know that you hear this all the time from your teachers, but it is terminology. Terminology is the foundation of your knowledge. If you are unable to use your terminology correctly, you're going to find that you won't be able to express yourself in your answers. But worse, you also won't be able to understand what the question is asking of you if the term is in the actual question itself. Now, I'm going to focus some extra time on the sections that I feel are a little bit more challenging for us, like the female reproductive system, the menstrual cycle that links with that, homeostasis, negative feedback. I think that's generally where we struggle the most, as well as the ear and the eye, because again, most of the application questions that we see in the final paper are on these three main topics. Now, with these challenging topics, we need to fix how we are taking our notes, how we are studying. And generally, students are studying in a very linear fashion, which means you are learning in order, right? You're going from the top of the page to the bottom of the page. You're making lists. Your notes seem to follow a silo or linear fashion, which basically means you've got knowledge here and knowledge here, but you can't actually connect those 2 points together. That's what I want to show you now. I want to show you a more unusual note-taking method. But this particular method is going to help you upgrade your marks. Instead of just recalling information, you will be able to take what you've learned and then interconnect it between all the ideas that you've covered. And this is going to let you upgrade your mark. You're not going to get 50% anymore. You're going to get 80% because you can show how you connect things together. The final thing when it comes to creating well-rounded answers is knowing the difference between the two key question words, explain and describe. Explain is when you are giving a statement and a reason, and you should let the mark allocation guide you as to how much detail you need to give. If it's out of 2, it's going to be 1 statement, 1 reason. If it is out of 3, still 1 statement, but now 2 reasons. Can go on to 4 marks, 5 marks. Depending on the mark allocation, it should guide you with like how much detail you need to be giving. Whereas for describe, that's going to be those questions where they're about 5, 6, 7, sometimes 8 marks long. Generally, we use describe when you're doing a process. So like describe assimilation, describe accommodation, describe the pupillary mechanism. Those are going to be things like how does it happen, where does it happen, why, when. You need to give a lot of detail. Let me give you an example of the differences of answers that you would be giving. So let's say the exam says explain fertilization. All you're going to do is you're going to explain fertilization in where it happens. So you're going to say fertilization occurs in the fallopian tube where the sperm cell and the egg cell nuclei fuse. And that's it. That's all you need to give. You gave a statement and you gave a reason. The reason being their nuclei need to fuse. Describing fertilization is very different. That requires a lot more detail. You would say things like, A haploid ovum is released from the ovary into the fallopian tube. A sperm cell has to swim all the way to the fallopian tube. The two nuclei fuse together to form a diploid cell, and that diploid cell undergoes mitosis in the fallopian tube before it moves on to the uterus. So you're essentially giving more detail to your answers. You're providing a little bit more information. And remember, you always want to paint a picture for the marker. You want them to know that you understand the topic. And if you can paint that picture in their mind, then they will award you those marks. So for beginners, what I suggest you do when you make these kinds of notes is we're going to start off with a central topic. Now, you don't have to put it in the center of the page, but I know that a lot of us like doing that because it's more familiar with us. You can put it anywhere on the page, actually, and I just like to put a little bubble around it. Okay, so I'm going to start off with the word follicle. And I'm starting on this because I know that menstrual cycle is one of our more challenging topics. It's a topic that we struggle with a lot. And I'm going to show you now how to build all of your knowledge around this one word. And so in the beginning, you can sit with your notes right next to you and build this. But over time, you should be able to remember this note and be able to actually construct it from memory and continue to build and build and build. So let's start off. The word follicle should start to jog your memory on certain things. So we've got follicle. Let's go in, like, for example, where we find the follicle. We find it in the ovary. We know that the follicle eventually becomes the ovum. And we also know that it secretes estrogen. And again, you're going to take these out of your notes because they're going to be sitting next to you. But now what you need to do is, before you list a whole bunch of things and you start getting caught up in making another linear note, is you need to see how these ideas link to the whole cycle. And as you read your note, you'll be able to actually figure this out. So let's have a look at, for example, the word follicle. So follicles don't just appear, right? So we're going to add in, how do we actually get a follicle? Well, that is because of the hormone FSH, which is follicle stimulating hormone. So that produces a follicle in the ovary. But we also know that as the follicle develops, the ovum, it secretes this hormone over here called estrogen. So it's important to show that you understand that they link together. But then estrogen is not just a word on its own. It also does something too. And if we link it to its purpose and its function, we know that it's linked to the endometrium and the fact that it regrows the endometrium. And again, you can make these bullet points, you can make them dashes, it doesn't really matter. Remember, you don't have to have an order or a look to this note. So we've got that idea. Let's go on to, how do we actually get the ovum out of the ovary? So we link to the word ovulation. Now, ovulation can't just happen, right? So again, let's pull in another hormone that assists with this, which is LH, and LH can be linked to ovulation. Now, if ovulation happens, then the follicle doesn't stay the same, does it? So the follicle is releases the ovum. And what you end up being left with is the corpus luteum. Now, you shouldn't be too concerned about how full your page becomes, because sometimes the first time you do this, it'll be very cluttered and full, and then other times you'll be a little bit better at spacing things out, so don't be too worried about that. Then we sort of think, well, okay, so there's the corpus luteum. How does the corpus luteum fit into the follicle, the endometrium? Oh, I remember. The corpus luteum secretes the hormone progesterone. So we add in progesterone. From adding in progesterone, we think, what does progesterone do? Well, it affects the endometrium. Instead of regrowing the endometrium, we can write here that it maintains it, right? And so we have this sort of very basic outline of everything and how it connects with one another, but this would only ultimately get you 50, 60% in an exam. How do you actually upskill yourself to be that 80%er? Well, you now need to move on to something called negative answers. Now, I would try and do all of the positive work first. So everything I've written here in black would be like positive answers. I would get that down. In other words, you'd be able to do this very easily for any topic before you try and do the negative answer stuff. But the negative answers ultimately allows you to be that 80%, that distinction person. So what we're going to do is I'm going to go back to our note here and we're going to say, well, what happens if these things don't occur? So hypothetically, if there is no FSH, what's going to happen? What's the knock-on effect? Well, if there's no FSH, there's going to be no follicle. If there's no follicle, there's going to be no ovulation. But now there seems to be more knock-on effects from that too, because if there's no ovulation, then there is no corpus luteum. No corpus luteum means no progesterone, and no progesterone means there's no maintenance of the endometrium. But we can take that negative answer further, because if there's no maintenance of the endometrium, a new thing that we can add in, and we can swoop it in over here, is that there is no chance for pregnancy. And not just no chance for pregnancy, but also maintaining a pregnancy. Now, you can fill this note as much as you can, looking back and forth between your textbook and your notes, and try your best to fill out any kind of negative answer that you can. This can, of course, go on and it can link to meiosis. It can link to the rest of the female reproductive system structures. It can also link into things like DNA replication and mutations. So it's a really good note-taking way, especially when you're starting off revising on a topic. But as you'll progress through your learning, you'll see that you'll be able to upskill, move into the negative answer, know how to explain yourself. And I haven't done too many explanations here. In other words, I haven't done like lots of bullet points. I haven't done lots of steps. Of course, you can include that as well. You can have step 1 and then you move it into step 2. And yes, it can be randomly all over the page, but there is a thinking to this. There is I want to call it a style or a model of learning that you're doing here, which actually is how your brain really works. It doesn't actually like to learn things in a linear way, and that's probably why you struggle to remember large quantities of knowledge. So let's move into the first topic of paper 1, reproductive strategies in vertebrates. Now, this is a small section, but I think we overlook it a lot when we prepare for exams. We think it's going to be just straightforward. They're going to give you like a couple of pictures of eggs and a couple of pictures of animals. And then they're going to be like, well, how do they reproduce with one another? What is their strategy? But what we're finding most recently is new examiners like to ask application questions. They like you to take your knowledge and then apply it to a certain kind of fish, a certain kind of mammal. Now, don't worry, you don't need to know a lot about mammals and fish and different species. They will give you enough information in the exam. But what we need to be able to do is apply. Now, the best way to study for this section is to use like a table. I find that the table lets you just recall very quick facts. You don't have to put a lot of effort into remembering a table. It's not like our non-linear note that we made earlier. This is a perfect example of quick recall that you can create easily at home. And I do actually have one of these tables for you in my cheat sheet study guide that you can use as well. So let me walk you through the table and show you what you need to know. So what I would like to do now is I want to clear up the confusion that we have around the reproduction in vertebrate section. So this is the table from my cheat sheet study guide. It might look familiar if you do have a copy of it. But essentially, we need to focus in on some of these key differences here. So what I've done for you is I've started off with breaking down external fertilization and internal fertilization, which are the two key differences. Because they start this whole process of reproductive strategies. And when you're learning all of this, we ultimately need to know just a few advantages and disadvantages. So let me just recap a few things quickly. External fertilization is when you have large numbers of gametes versus internal, generally, you have fewer gametes. And what does it mean by generally? Well, external fertilization, we're looking at hundreds, thousands of eggs, versus internal is going to be anywhere from 1 egg to 2 eggs to even up to 8 to 10 eggs if you think about other mammals that have like litters of offspring. That's still a small amount of individuals. But we also need to look at the disadvantages. So if you have a lot of offspring, generally it is a waste in terms of how many eggs you make. And the other disadvantage is external fertilization is not certain. However, internal fertilization also has disadvantages. Even though it ensures that the egg and the sperm cell are close to one another, it's difficult to find a mate. You definitely have like mating seasons, so you have fewer reproduction opportunities. And the big one is longer gestation, which means you're either pregnant for longer or you are looking after your offspring for longer, because generally most internal fertilization animals are animals that have long-term parental care, or they sit on their eggs, or they keep their egg internal until it hatches, and then they still look after it once it's hatched. Which brings me to my next point. Often what we don't know is we don't know the differences between ovipary, ovovipary, and vivipary. And I know those words all sound the same, but they are not the same. It's important to know also that their spelling must be very clear in the terminology section. If you confuse the terminology between these three and you like throw in a random V somewhere, you might end up losing that mark in your paper. So we want to just try and avoid that as best as possible. So what I'd like to do is use an example to show you how we confuse the different kinds of fertilization and whether or not it lays an egg, and show you what to look out for. Now, the two examples I'm using both lay eggs, but everything else about them is different. And so that's why we often get things wrong. We focus on the egg laying and we don't focus enough attention on the type of fertilization, the type of parental care. And so we get caught up on just, is there an egg? Isn't there an egg? So first things first, let's talk about frogs. So frogs are an example of external fertilization. They are also an example of animals that have ovipary, or they are oviparous. And so that means their eggs are on the outside of their body. Now, here's the thing. Frogs lay eggs, right? Which means these eggs are outside their body. They are external. But for some reason, we think that these eggs are not eggs because they don't have a shell. Remember, when we talk about eggs, we're talking about the amniotic egg. Okay, it doesn't have to have a shell to be an amniotic egg, but I'm going to clarify that later in this video as well. So they lay eggs, and generally their eggs have less yolk in them. Why? Ultimately because they're going to be like slightly smaller organisms generally. They're going to have less development within them. And remember, yolk is all about nutrients. Now, frogs lay their eggs and then they swim away. So there is no parental care either. The fact that there's no parental care means that there is a little amount of energy put into actually making offspring. Yes, they make a lot of eggs, but that requires the least amount of energy in total. Looking after babies is the big deal, right? So this is a frog. It's got external fertilization, but it is ovipary or oviparous. Let's compare it to another oviparous organism that has the opposite of all of this. Now, this example is the complete opposite of the frog in that it is internal fertilization in penguins. It does have parental care. But the key fact here that I'm trying to show you is this animal still has the egg-laying potential, or they are oviparous. And I think that's what I'm trying to clarify with you is you can lay eggs, but your fertilization can be different and your parental care can be different. Penguins, for example, have mating rituals. So that's more energy in requiring mates. So mates require more energy. Not only do they require more energy for fertilization because it's internal, but also there is, as I mentioned, parental care. Parental care of this egg, because they lay their egg and then they look after their egg. Unlike frogs, swim away, never see it again. This kind of ovipary also has few offspring as well. So they don't make a lot of eggs. So when we learn this, what we're not trying to do is we're not trying to label every animal that lays an egg the same way. We need to know that, yes, birds lay eggs, fish lay eggs, amphibians lay eggs, but the way in which they make them, look after them, what they do with their offspring afterwards is all very different. Now what I want to move on to is, where do we keep getting it wrong? And this is going to be an occurring theme throughout this video, because I want to show you the most common mistakes I see in final exam papers, starting off with the fact that we don't know what an amniotic egg is. Okay, we confuse it with a human egg, which is technically part of an amniotic egg, except we don't have like a shell around it. So there are some differences. So this is an amniotic egg versus this being a human egg. And in exams, you will need to be able to label these things as well. So for example, in our human, what's missing in this picture, actually, I'm just going to add it in over here, would be the nucleus. So you've got to be able to label this. We've got to know that that is the nucleus. This is the cytoplasm. I'm just going to shorthand that. In some diagrams, they have little cells on the outside here, which will be follicle cells. So we know how to label the human, but we often don't know what we're doing with the animal amniotic egg, which is this one over here. And also another danger zone for this is there are a lot of structures inside the amniotic egg that we confuse with when it comes to the human, let's call it the implantation of an egg. Like we confuse what is the purpose of the chorion in the egg versus a placental mammal, so something that will grow with a placenta. They are not the same. I want you to keep in mind that when we learn the amniotic egg, we are learning about an animal that is either outside of its parent, so it's not attached to its parent anymore, or if it's an internal egg that they hold onto because they have ovovipary, like sharks do this. They have eggs internally that they look after until they hatch. I need you to know that the structures inside this amniotic egg are very different in purpose than what we see in the human reproduction. So what I'd like to do is just quickly run through these structures and just brief you on what you should be ready for in your exam. So first things first, yes, you will have to be able to draw this amniotic egg. The likelihood of that happening is pretty low because you can see it's got a lot of detail going on in there, and they don't want to like slow you down at all. So generally you're going to be labeling, but I just want to run through what all of these labels are. Starting off with number 1 is going to be the shell. Number 2 is going to be the yolk. And earlier on I mentioned that the yolk is a source of nutrients. I'm just going to recap here and remind you that if you are a land animal, you generally have a large yolk. If you are an aquatic animal, then you are going to have a smaller yolk. And that is generally, it is a generalization, but it's generally because of how much nutrients you need to provide that organism. Moving on to label number 3, this is something called albumin. Now this particular layer or substance is what you would consider egg white to be, like the egg white part of an egg. Albumin is only found in amniotic eggs. It's not found in human reproduction, so don't try and label that on a cross-section through like a fetus and an embryo in a human. It's not going to be there, so let's not confuse that. Then number 4 is also something that is unique in our eggs, which is the alientois or alientois. Just depends on how well you pronounce French, because that's where the word is coming from. But the alientois' main purpose is for nitrogenous wastes. If you think about it, you're inside this egg for 6 weeks, a month, who knows, depends on the animal, but your nitrogenous wastes need to go somewhere. And so what the alientois does is it stores wastes. And that is ultimately, it's actually sort of like, the only way I can describe it to you is it disappears after the egg hatches. So it doesn't just like magically disappear. What it does is it forms a sort of pocket that attaches itself to the side of the shell, and that means that when the little baby bird hatches, it leaves the alientois behind. It's no longer attached to it. Because again, remember, if you're inside an egg, you don't have a placenta, you have no one to get rid of your waste products. So you need something to store your waste products until you actually hatch. Number 5 is going to be our embryo. And number 6 is a tricky one because I know you think it's a layer, but it's not actually pointing to the layer. It's pointing to the substance that is secreted, which is the amniotic fluid. I know you don't think of animals and shells having amniotic fluid, but they do. I'm actually going to jump to their number 7, which is the amnion. The amnion is a layer. It forms around your embryo, secretes the amniotic fluid, which remember the amniotic fluid is for safety. It is also for temperature regulation. This one, again, shares a lot of characteristics with the human reproductive cycle as well. And last but not least, the one I really want to bring your attention to, which is the chorion. Now, why am I bringing your attention to this one, this outer layer? In animals that lay eggs, the chorion is there to allow for gaseous exchange. Because if you're trapped inside of an egg for months, how are you going to exchange gases? You can't just magically bring the gas through the shell and then into the embryo. You need a diffusion membrane, and that's where the chorion comes into play. Now, the chorion in the egg is for gaseous exchange. However, we often confuse this with the chorion in mammals. In mammals, the chorion is going to become the placenta. We start off with chorionic villi. Those chorionic villi grow into the chorion, and then the chorion becomes the placenta in mammals. This is where we make a big mistake, and we confuse these two with one another, and we think that the chorion stays around forever in mammals, but it doesn't. It becomes the placenta. And remember, the placenta is ultimately the key, the defining thing that separates mammals from other egg-laying organisms. So now that we've come to the end of reproduction in vertebrates, what I want you to do is see, do you actually know anything on this topic? And what I've done is I've provided you 2 sections of notes. I've given you some recall questions. If you can do the recall questions without looking at your notes and you get 100% when you mark them, great. You're on the road, you're doing well, we're going to get 50%. But nobody wants just 50%. We want to get 80, 90%. And that is where you can move on to the application questions. They are a little bit more challenging. And I have picked some more difficult, tricky questions because they require more elaboration and a little bit more depth of knowledge. But you can go and attempt those now and then return back to the video so we can continue into the next topic.